Hi everyone, I'm Vanshlata and I'm glad to be presenting my paper at DVCon 2021. It is titled Accelerating SoC Verification Sign-Off Using Save and Restart and Dynamic Test Reload Enhanced Regression Flow. It has been co-authored with Garima Srivastava and Divya Madhavrapu, who are my colleagues at SSI Bangalore, and Seonil Choi at Samsung Electronics Korea. We know how fast the trends change in consumer electronics these days. The plethora of features add to the complexity of the design and increase the scope of verification as well. Nevertheless, to be a market champion, we need to deliver the best in the shortest time possible. With increasing complexity of the SoC designs, design and verification flow become tremendously challenging. We need to take care of a lot of things to deliver a bug-free silicon, like identifying and exercising all the use cases, accommodating lead spec and implementation changes, ensuring security and functional safety, ensuring regression and coverage closure to avoid multiple spin-offs or metal ECOs. Limited IP and VIP licenses and LSFQ is also a concern. It's quite difficult to keep up with the shrinking time to market goals when there's so much to take care of. Improved fab tech like the 7nm or the 4nm also puts stress on power, performance, and area concerns. This aggravates the tight schedules and allows for lesser time for verification and coverage. Although it's never possible to exercise 100% scenarios of an SoC for verification closure, it's pertinent that major bugs and loopholes are caught before a metal tape out. Here's a survey by Wilson Research Group. It suggests that 52 to 57% of a project's time is dedicated for verification. Debug cycles form a major part of verification and take around 44% of engineers' time. This is shown in the figures 1 and 2. Now, let me tell you about the background of the problem statement here. As the number of IPs and processors increases in a design, the verification scope increases. The typical SoC has anywhere between 5 to 10K tests. Most of these test scenarios will run for hours and hours before they fail. Now, simulators have advanced, but a lot of time is still spent waiting for the test to complete. This amounts to a lot of simulation overhead. This brings us to the idea of save and restart. All tests have to do some initial setup before starting a test scenario. Running this phase multiple times for every test takes a lot of time again. If we can use the data and state of initial setup and common boot sequence for multiple tests, it would minimize the simulation time. This is illustrated in the figure 3 here. Existing simulators support save and restart, but with few limitations. In our approach, we have used the PBSR, that is, the process-based save and restart. This is provided by Cadence. PBSR integrates with itself the DTR, that is, the Dynamic Test Reload methodology. Here, a package-based test bench is used to add new code to the existing environment. This considerably reduces the test bench development time. In DTR, we have a DBS, that is a dynamic base snapshot, and it can be dynamically referenced by a DTS, that is the dynamic test snapshot. A DBS is a time zero snapshot that contains the full model of the DUT, TP, initial UVM test classes, etc., until the saved point of interest. A DTS contains a model of new system verilog package that is used for the override and a DBS that it could be linked to. The same has been illustrated in figure 4 here. A custom integrated central regression script has also been developed which uses data from an input Excel file. It aids in identifying tests enabled for save and restart, creates the regression suits, compatible builds, user-defined snapshots, and enables restart of the test from the saved point of interest using UVM factory override for multiple test scenarios. The time saved here is attributable to the common checkpoint that forms major portion of the test initialization. This can be to the tune of 50 to 70% of the simulation time. A sample input Excel sheet is shown here in figure 5. Now let's get into the implementation part. There are two methods each for save and restart. The save can be done using the TCL commands or the inbuilt $save task in Verilog. Restart command can be done using command line options or the UVM factory override. Both can be used interchangeably, and in our project we have used the TCL commands for save and UVM factory override for the restart process. This section provides with the syntax for creating the DBS, that's the dynamic base snapshot, and the dynamic test snapshot. A few extra switches are required here compared to a normal simulation. Make DBS snap is for creating a snapshot, and DBS snap is for DTS referencing. DBS name and snapshot name provide the corresponding names. Process underscore save is mandatory to enable the PVSR in the first place. UVM no autocompile is required to avoid recompiling the libraries during the DTS creation. Input files like the save.tcl and the restart.tcl contain the conditions for stop and the restart. Save.tcl file uses the command stop with options for synchronization. Restart.tcl has UVM factory override commands. A typical example has been shown in the figures 7 and 8 here. Yeah. So the next section here deals with the theoretical calculations. Let's consider a test taking X time for bring up and Y time for remaining simulation. Regression with n tests, when run with and without save and restart, yields total time saving of at least 50%. The cumulative time saving would largely depend on the total number of snapshots that are created and the number of tests to be run in the regression. Eventually, the more the difference, the more we save. Now let's get to the practical results. When deployed in a live project, we observed improved regression time, saving 10 to 90% per test. The debug efficiency also increased due to shorter runs. This gave us more time for debug. Considerable savings of 2 to 3 weeks of time per label and lesser incremental runs were also observed. We also came across a few limitations. Tests are usually UVM component, but hierarchy can't be changed once UVM phasing has started. So UVM sequence, which is derived from UVM object, is used to create tests. This enables on-the-fly factory override in PBSR. Though it needs environmental changes, it's a one-time effort. DTR needs package-based environment for modifying sequences on the go. This is again an environmental change and a one-time effort. During restart, we need to make sure that the TCL override command in the restart.tcl is executed before the sequence is created. So proper synchronization of the phases needs to be ensured. Also, only derived classes should be used for sequence overriding of the base classes, else we'd come across some errors. Also, the RTL hierarchical references in TB cannot be used. Instead, the connections need to be defined using the virtual interfaces. Now, despite all these limitations, the productivity improvements far outweigh the time and effort invested for environmental modification. And this can also be carried forward to other projects without much effort. The table here shows the comparison in time taken by SNR enabled regression and normal regression for few of the blocks. We can see that the time savings ranges from 20 to 80% across the blocks. This can further increase depending on the number of snapshots and the number of tests in the regressions. The same has also been illustrated as a graph, and we can see the time difference in the SNR versus non-SNR is almost double. In conclusion, we can say that the process-based save and restart along with dynamic test reload methodology has significantly reduced simulation times, improved license utilization, increased debug efficiency, facilitated early bug identification and closure, and hence early verification sign off for our current project. So that was all. I'll be happy to take any questions that you may have now. Thank you.